In this video, we are going to talk about how to evaluate limits of a trigonometric functions. In evaluating limits of a trigonometric functions, there are two formulas that we need to remember. The first one is the limit of sine x over x as x approaches 0 is 1. And the second one is the limit of 1 minus cosine x over x as x approaches 0 is 0. So let us confirm if the given formulas are correct. The first one, let us prove that the limit of sine x over x as x approaches 0 is 1. So let us identify a number which is closer to 0. So let's say if we have sine 0.1 divided by 0.1. If you are going to type this one on your calculator, make sure your calculator will be in the radian mode. So sine 0.1 divided by 0.1, that is 0.998. So let's try another number which is more closer to 0. So let's say sine 0.01 divided by 0.01. If you are going to plug this one on your calculator, you are going to have 0.99998. So as you can see, as x approaches 0, the function sine x over x approaches 1. So therefore, we prove that the limit of sine x over x as x approaches 0 is 1. What about the second one? Let us try a number which is closer to 0 to prove that the limit of 1 minus cosine x over x as x approaches 0 is 0. So let's say we have 1 minus cosine 0.1 divided by 0.1. If you are going to type this one on your calculator, we are going to have 0.05. So let's try another number which is closer to 0. So let's have 1 minus cosine 0.01 divided by 0.01. If you are going to simplify this one using your calculator, you are going to have 0.005. So let's try another number which is more even closer to 0. And let's see what happened. So let's have 1 minus cosine 0.001 divided by 0.001. If you are going to simplify this one, you are going to have 0.0005. So as you can see, as x approaches 0, the function 1 minus cosine x over x approaches 0. So therefore, we prove that the limit of 1 minus cosine x over x as x approaches 0 is equal to 0. So let us use this information in order for us to evaluate limits of a trigonometric functions. So let's start and let's have an example. On the first example, we have limit of sine 5x over x as x approaches 0. If you are going to simplify this one, we are going to have 5. But how can we find the solution of this expression? So if we have limit as x approaches 0 of sine 5x over x, so let us multiply this one by 5 over 5. Then let's have limit as x approaches 0 of sine 5x. Let's move 5 to the side of x, and that will be 5x times 5. And let us represent y as 5x. Therefore, we are going to have limit of y approaches 0 of sine y over y times 5. And we all know that the limit of sine x over x as x approaches 0 is equal to 1. Therefore, this expression is equal to 1. And that is 1 times 5. So 1 multiplied by 5 is 5. And this will be our answer. On example number 2, we have limit of sine 2x over 5x as x approaches 0. So by merely inspection, we can say that the value of this expression is 2 over 5. But how can we find the solution of this expression? So let's say we have limit as x approaches 0 of sine 2x over 5x. So let us multiply this one by 2 over 2. And then let's have limit as x approaches 0. Let us write sine 2x divide by, so let us replace 5 by 2. So we are going to have 2x on the denominator times 2 over 5. And let us represent y as 2x. So let's have limit of y approaches 0 is sine y over y times 2 over 5. And we all know that the limit of x approaches 0 of sine x over x is 1. Therefore, this expression is equal to 1. And that is 1 times 2 over 5. And 1 times 2 over 5, that is 2 over 5. And this will be our answer. What about example number 3? The limit of sine 7x over sine 3x as x approaches 0. If you are going to simplify this one, we are going to have 7 over 3 as our answer. But how can we find the solution of this expression? So let's have limit as x approaches 0 is sine 7x divided by sine 3x. So let us multiply this one by 7 over 7 and 3 over 3. Same with x over x. Then let's have limit as x approaches 0. Let us write sine 7x. And then let us replace sine 3x by 7 and x. And that is 7 over x in the denominator. And let's have 7 over sine 3x multiplied by 3 over 3 times x. And then let's have limit as x approaches 0 is sine 7x over 7x. Then let us replace 7 by 3x, and that is 3x over sine 3x multiplied by 7 over 3. So let us represent y as 7x and w as 3x. So let's have limit of y approaches 0 is sine y over y times the limit of w approaches 0 is w over sine w times 7 over 3. And we all know that if we have limit of sine x over x as x approaches 0, that will be equal to 1. So therefore, this expression is equal to 1, and this will be the reciprocal of this expression is also equal to 1. Therefore, we are going to end up with 1 times 1 multiplied by 7 over 3. 1 times 1 times 7 over 3, and that is 7 over 3. And this will be our answer. On example number 4, we have limit of tangent x over x as x approaches 0. So let us rewrite this one as limit as x approaches 0 is tangent x over 1 times 1 over x. And we all know that tangent is equal to sine over cosine. So let's have limit as x approaches 0 is tangent, and that is sine x over cosine x multiplied by 1 over x. And then let us replace cosine x by x, and that is limit as x approaches 0 is sine x over x times 1 over cosine x. We all know that this expression is equal to 1. And then cosine 0 is also 1. Therefore, 1 times 1 minus cosine x, or cosine 0, that is 1. That is over 1. So let's simplify. Let's have 1. 1 divided by 1 is 1. And that is 1 times 1 is 1. And this will be our answer. On example number 5, we have limit of tangent 4x over 3x as x approaches 0. So by merely inspection, we can say that this expression is equal to 4 over 3. But how can we find the solution of this expression? So let us write this one as limit as x approaches 0 as tangent 4x over 1 times 1 over 3x. And we all know that tangent is sine over cosine. So let's have limit as x approaches 0, that is sine 4x over cosine 4x times 1 over 3x, and let's multiply this one by 4 over 4. Then let's have limit of x approaches 0. So let us replace cosine 4x by 4 and x. And that is sine 4x divided by 4x. And then let's have 1 over cosine 4x times 4 over 3. So 3x will be replaced as cosine 4x, and 4 will be replaced as 3, and x will be on the denominator of sine 4x. So let us represent y as 4x. So let's have limit of y approaches 0, and that is sine y over y times 1 over cosine y times 4 over 3. So we all know that the limit of sine x over x as x approaches 0 is 1. So if you're going to have this expression, you're going to have 1 times 1 over cosine y. So we have cosine, and the value of y is 0, times 4 over 3. So we all know that cosine 0 is 1. And that is 1 times 1 over cosine 0 is 1 times 4 over 3. So let us simplify. So this will be equal to 1. So 1 times 1 times 4 over 3, that is 4 over 3. And this will be our answer. On example number 6, we have limit of 7 times the quantity of 1 minus cosine x over x as x approaches 0. So if we are going to simplify this one, we are going to use the formula limit of 1 minus cosine x over x as x approaches 0 is 0. Now, to simplify this one, let's have 7 times the limit of x approaches 0 of 1 minus cosine x over x. So this expression is equal to 0, and that is 7 times 0. And 7 multiplied by 0 is 0, and this will be our answer. On example number 7, we have limit of sine square x over x as x approaches 0. So to simplify this one, let us have the idea of sine square x is sine x times sine x. So let us write this one as the limit of x approaches 0 is sine x over x times sine x. And we all know that the limit of sine x over x as x approaches 0 is 1. So if we have this expression, we are going to have 1 times the limit of sine x as x approaches 0. And if we are going to substitute the value of x into the given expression, sine 0 is 0. So therefore, this expression is equal to 0, and that is 1 multiplied by 0 is 0, and this will be our answer. On our last example, we have limit of sine x squared over x as x approaches 0. So let's have limit of x approaches 0 is sine x squared over x. So let us multiply this one by x over x, and let's have limit of x approaches 0 is sine x squared. So let's multiply x and x. It will give us x squared on the denominator times x. So let us represent y as x squared. So therefore, we are going to have limit of y approaches 0 of sine y over y multiplied by the limit of x approaches 0 is x. And if we have limit of sine x over x as x approaches 0, this will be equal to 1. So this expression is equal to 1. Multiplied by, if we are going to substitute the value of x, we are going to have 0. Therefore, 1 multiplied by 0 is 0, and this will be our answer. So I hope you will learn from this lesson. Thank you so much for watching, and God bless us all.